Hello, I run an audio video transfer business, and you'll have seen recently that I went and collected a big mountain of video recorders, a bootload of video recorders. But also in amongst that collection were some digital time-based correctors, and these are absolutely vital for video transfer businesses such as myself because they stabilize the video signal and can do much more besides. They are now really hard to get. High quality ones are extremely sought after and expensive in this business. But apparently these are all faulty. Let's find out. So what do we have? This is a particularly useful piece of equipment. It's a DPS 375 SP. I don't know if the SP makes any difference, but I have already 4 of these units. They are very useful because they can take the dub input from a U-matic video recorder and convert it to something that we can use on modern video capture equipment, and also have a digital dropout compensator built in. So extremely useful piece of kit. These 2 units made by a company called GTH Electronics. Gordon Hathaway, I've interviewed him. I did a 1-hour deep dive into these units, especially this version. This is the one that's a time-based corrector, and it can do NTSC and PAL and CCAM input and output, and is the very useful piece of equipment. I have 10 of these already, the biggest collection in the world. This is its kind of Mark 1 version. It's more of a proc amp, just color adjustments and various trimming. You can sort of trim bits off the image. So these, I'm not particularly excited about this model, but this one I'd really like to see if I can get that fixed, possibly with some help from Gordon. And we also have, I've never seen the user manual for the DPS 375 before. This one's the SP version. The user manual doesn't seem to be any different then for the non-SP version, and it includes the original invoice. It costs some £3,000, and that was on a special deal. We've actually got price lists here as well. The original price of this equipment, the list price of the DPS 375, was £3,900. That's plus the VAT, thank you very much, in 1991. So they were stunningly expensive pieces of equipment. We've got all the brochures and everything here. Maybe I'll scan this in because I don't think anyone's managed to document these before. Correct me if I'm wrong. We've got internal controls and external controls. In behind here are some dip switches, and you can set up those switches, and I'm not sure why you want to. Right, so we can read what those switches do. I've often wondered. And the full user manual. Well, U-matic dub, you see. Oh, this is so useful. I only wish they had the schematics in it. That would have been really useful. But no schematics, no. Okay, right. Which one should we look at first? The DPS 375 or the ACE box? Let's look at some of the markings on them. So this one says scrap, faulty. Not sure what the fault is supposed to be. I guess that'd be a quick one to test, wouldn't it? And similarly faulty, it says. I have several of these, as you know, and I have the power supply. Right, here's one of my collection of these things. I have a particular firmware on this one that gives me certain features. This one will be slightly different firmware. So the power supply is pretty generic, actually. Almost anything, AC or DC, around about 9 volt, because it has a built-in regulator. So we'll at least test that initially, just see if we can get some color bars out on the monitor. That'd be a quick thing to try, won't it? And then the DPS 375 has a heap of markings on the lid about intermittent faults. So we'll get to play with that too. I think the first thing we'll do is looking at the one that is actually TBC, this one. We'll just see if it powers up. Okay, this is mine, the one that I've had for a long time, and we've got a mains adapter there. We'll power it up and put it into test mode and display it on the monitor. Right. So we switch this one on and go test select, and we get our colour bars on the TV, right? Now I can cycle through blue, red, and then when it's in black, that's because there's no video input. So that's what it should do. Let's try this one first. Now there's no colour bars on. Is there colour bars on this one? I'm not sure if this one has colour bars. The one that's not a TBC. So that'd be something to try. Okay, so switch it on. Lights up. Test select. So far so good. So at least that aspect of this one is working. Let's try the non-TBC version. Do we have a poor contact there? Or is it my connector? Okay, I'm having to hold the plug, which is bad. So that implies that there may be a problem with the socket. And test select is doing nothing. So this one does appear to have a fault. Alright, so we may have a bad input socket on this one, which is not the TBC. But then I couldn't get any test select from it anyway. So we do appear to have faults with that one, but I'm not particularly excited by this model. We could play with it later though. The next thing I think to do is to feed this to this one, of which I'll need another mains adapter. So I'll go and get one of those, and we'll use composite video or S video, whichever cable I come across first, to go from output to this to input to that one. Okay, I've set up a power supply for both units. We have S video out of my known good machine here, going into S video in. And on this machine, the way it works is in is composite, out is S video. So we should have the output of this going into the input of our one we're testing. So this is our one we're testing, and we know we have colour bars on that. Right, and now, does it work when we ask for colour bars on our known good machine? No. Nothing out. Well, if the fade button's pressed, it will have that effect, but no. And we're definitely in S-video mode, not composite mode. So there is no output. That's interesting. What about if I increase brightness? Nothing. Oh look, I released the manual button. That's the fade feature. I've released the manual button and our picture's fading up. It's not the same firmware as my machine, so I'm not quite so familiar with it. Right, so there's fade in and out. Very slowly. If I press this button, does it fade faster, does it? Yes, there we go. But I don't use the fade function because I have different firmware. So it looks like it's working. Let's try a few tests. Give it a red input or a blue input. Yes, they're fine. Invert. That looks correct. Not a feature I ever use. Bypass. Yep, that seems to be bypassing. It's dropping the brightness because the brightness control. There we go. So the brightness control is working. Contrast. Sharpness. You won't see so much on that one. Digitize. Never saw the point of this feature. Don't like it. That NTSC looks a bit ragged. Have I got something set wrong? That's C-cam, which the TV won't support. Yeah, very ragged edges. I don't know if you can see that. The transitions are quite jagged, but that might be normal. NTSC is not a pretty thing. Let's go back to PAL. Colour saturation. Yeah, that's working properly. Colour balance. Like tint, I think. And colour shift. We should see the colours move. Yes. And now we should be able to up and down the red, the green, and the blue. If we had a vector scope hooked up, we'd see a little bit more information on what it's doing. I do have a vector scope, but it's a bit of a nuisance to set it up. So that appears to be a good working unit. I will have a quick word with Gordon and see what he can tell me about what firmware this has and whether I can upgrade the firmware to the same as this. Though I may not want to, because I like to keep a few of these back in the original firmware. One of the reasons being that this version has CCAM and NTSC 4.43 deselected by default, and you have to press a particular key sequence, power it up with the color shift button pressed in order to re-enable CCAM and NTSC 4.43. And for one or two setups, I prefer it they are enabled by default. I might keep the original firmware. Shall we also, since we're here and we've got that working, shall we try the non-TBC box as well, just see if we can do the same thing? Right, I've hooked up my known good machine to the non-TBC version, and we will get we have an image, but with lots of rolling noise going through it. So I'm thinking, if my mains adapter is AC output and it's relying on the rectifier and smoothing capacitors in here, then the smoothing capacitor may be at fault. Oh, that's interesting. So how does this work then? So you can... How do you work this? Manually? Oh yeah, that's it. Look, you can trim the edges of the picture. You can trim all the edges of the picture, I think. Yes. Top and bottom in particular could be useful. So you can trim off the head switching noise, which obviously these days I tend to do, with video software, video editing software, to get rid of head switching noise. But you could do it before you record it. So this was useful, especially if you're dubbing to another tape or something like that. Right, I don't know if you get any control over cropping the top and bottom to a different amount, possibly not so much. Looks like they go as a pair. Right, so that's the one feature you get on the non-TBC version, but it's not a feature I particularly require. And beyond that, the features I think are quite similar. Yeah, saturation and the color balance, tint if you like, and color shift, that's important. Can you shift the color up? Yes, you can. We won't see that here, but every copy of VHS or Beta, the chroma drops by one line relative to the luma. So it can be useful to press this and put the chroma back up again. But you can't see it on this because this image doesn't have any vertical information. But that seems to be working then. It just looks like it needs a bit of attention to its built-in power supply. So I think I will fix that. Yes, I will fix or have a go at fixing that. These cases are quite tricky to take apart, but we will work on that one later. This box, that's my known good one. This one that was supposed to be scrap appears to be in perfect working order. Maybe someone didn't quite understand how to use it, or they had a bad power supply. Right, so the next thing we want to test really is the DPS 375. Okay, next is the DPS 375. It says CVBS bypass US or intermittent, I think. YC proc OK intermittent. YC out OPS on test, not sure what that says. Test output, there's got some ticks. Front rotary encoder, OK. Functions intermittent. A bit vague about exactly what the problem is. And I just love the fact that we've got the original service, well, not service manual of LAS. I don't think that's ever got out into the wild, but the original user manual. This is one of the ways I use it, which is the system connections here for U-matic. I do this very thing. Okay, this is how I use these machines. Dub out. Don't forget the PAL out, which is composite video. If you don't do that one, you don't get color. And the dropout compensator with the RF output envelope. And sync in. I've never made that connection before. And I don't know why you need it. Interesting. Don't know. Don't know why I'd need that. So that's an interesting connection. Perhaps I should try that. Right, so before we power this up, I'm going to take the lid off because I want to see if the fans run at the back. Their fans have a habit of not working. Okay, so I can now see the fans. Just check that they seem to rotate. Yes, they seem to be clear to rotate. power supplies in there. There are a lot of tantalum capacitors here. I did have one explode on one of these once. That was fun. Right, perhaps I shouldn't show you this. I've mentioned this chip before because I may have had some tiny part in helping to manufacture it, because I used to work for Plessey Semiconductors at the time. This is a CLA 3155, so it's quite one of the older uncommitted logic array type devices. They would make the bulk of the uncommitted logic, and then it would be made as a metal, what they call metal wafer, which means it's got a metal top, which is not assigned, and then the customer would say, oh, I want these various connections, these various devices inside my digital IC, and we would do the last few stages where we would go from the metal wafer bank to the finished product. Is what you'd now use an FPGA for. And then I worked initially, when this was made, I had been working in the department that actually made the ICs in the wafer fab, and later on I worked in the test department where we would test the ICs before sending them to the customer. And that's why I happen to know that, okay, this device is made, and that's normal date code, year 92, week 24. I'm not sure what that means, but PR means it was a prototype. This was not a fully released part, possibly because the volumes never got high enough for it ever to reach full production status. So PR means prototype. There we are. I've told you something I'm not allowed to tell you. Okay, I'm almost scared to switch this thing on, but it's plugged into an isolation transformer. Let's switch it on. Both fans working. A little noisy, but not too bad. I could squirt a little light lubricant into them later. Okay, let's do some more testing. This ACE unit, the one that was supposed to be faulty but isn't, we have that hopefully in test mode. So that's now outputting color bars, and the S-video signal is going into here, and composite video is feeding out there. So first thing I'll do is try its internal signal generator. So that would mean switching from process to test, and bars. Interesting. Sort of have bars, but sort of don't. Now, what setting have I potentially got wrong that's causing it to give us a unsynchronized output? It almost looks like it's NTSC. It does actually look a little bit like NTSC, because the frame rate's wrong and the amount of lines is wrong and the color's missing, so it looks like a bad NTSC conversion. But this is a PAL only unit, and if I go to process, right, that's processing this signal now. So if I go through here, no, that's not working. That should be processing that signal, and it clearly isn't, because if I switch this off, it stays there. Right, so look, this is in process here. I don't quite see it. So the TBC should be active. That should be in bypass, and that should be test. In test, we're getting that. In process, we're getting an even scragglier version of the test signal. And in bypass, we're getting nothing at all. Though that could be because we've got the wrong input. So I'm not getting anything from the input. And in test, I'm getting a horrible color bars. And in process, oh, look! That's interesting. Is that from here? No. No. That makes no sense at all. So I'm getting color bars, in fact, even when there's got no input signal. So it's not processing. I'm getting colour bars in the process mode. And when I go to test, oh look, things are improving. It's almost like capacitors are improving. So now our test signal looks valid, which it didn't earlier. And if I select the different bars, they look valid too. So things seem to be quietly fixing themselves, which is a little concerning. But when I hit process, I get a wonky version of the colour bars, and bypass, I don't get anything at all. I'm inclined to think it does have faults, for which we're not going to be able to do a lot because we do not have schematics for this, and it's non-trivial. There's layers of boards in here as well underneath. Wouldn't be the easiest thing to fix even if we did have a schematic. But it's interesting that we now have the test signal correct. That's 100% perfect. It's just that when we select process, we get that and we shouldn't. And when we hit bypass, we don't get anything at all. I wonder if it might be better with a composite connection, actually. Let's do composite in instead of S-video in. Just switch it off for a second while I hook that up. Okay, to my absolute surprise, the output from this TBC in composite mode, the little ACE one, is being fed through this while it's switched off. I didn't know it did that. That's a nice, interesting feature. Right, okay. So let's switch it on now. So in bypass mode, we do indeed get the bypass signal straight from the ACE TBC. Good. And in test mode, we get its own internal signal generator. And we know that it's that one because we can change the pattern. Okay, so everything we're seeing right now is normal operation. It's when we hit process, which signal are we getting? We're getting that one now. Didn't get that before. So that's presumably because it has a valid input on the composite input. I don't know why I can't seem to access the S-video input. Not pressing the right button somewhere. How do you get S-video? I guess I could read the instructions. That might be an idea. We'll do that in a minute. So now if we select these different inputs. So PAL, which means composite video. YC443, YC... You see, I don't know why these are doing this. But it appears to be working. So if I do something like adjust the chroma level, I should be able to make it monochrome. So here we got the chroma level control. See, it's got, I don't can quite see it. Can't quite get everything on the screen at once, unfortunately. But C level, that's labelled. So yes. That looks right. Y level, so we take the brightness down. Yes. Chroma phase. Not seeing anything on that. Maybe you would need a... Yeah, I think we might need the vector scope to see that. And black level. I'm not sure if we'll see much on the black level. Yep, you can see it brighten. Yeah, it's brightening slightly. You can just about see that. Okay, so the faults were apparently, well, intermittent. And I suppose I'm sort of seeing that it's intermittent because it wasn't working. Not all these features were working when we first powered it up. So we may have a bad capacitor or similar somewhere, but if it keeps working once it's been on for a while, is that such a problem? We don't have that many electrolytic capacitors I can see that could be a cause. There's one there. I'd have to take the boards up to look for others, but I'm not seeing many electrolytic capacitors that could cause these sort of problems. There is the power supply, of course, but I think if we had power supply problems, the symptoms would not look like this. So from what I see at the moment, that does appear to be a working unit. Intermittent, well, yeah, a little, but not bad enough to be a problem. Oh look, there's some more capacitors there. 16 volt, 22 microfarad. There's a few that might be worth checking. They're only going to be associated with power, I think, anyway. Looking at the way they're connected to some very big tracks right next to the power supply connector there, I think that's just a bit of power filtering. I think I'm going to apply a little WD-40 to the fans to see if that quietens them down. So I'll switch it off. Okay, I may not have got through to the bearings, but let's see if that's going to help at all. It might quieten down over a period of some minutes. I'm just going through some of these settings to make sure they're all at the 0 positions, and some are not. Well, that's going a bit slow now. Odd that some of these settings, the speed of the dial is different to others. So this one, YC phase H, doesn't do much when I turn it, but some of the others work much more naturally. You can see that. That's working fine. So there's nothing wrong with the encoder, but for whatever reason, some of those controls don't. Those couple of controls seem to be a bit slow to respond, but that's really not important. I could hook this up to the vector scope, but it's a bit of a carry-on to do that because I have to connect this to a device that will convert to SDI, so I use a digital Betacam machine. And then that goes to the vector scope because the vector scope is SDI only. I have also some computer-based SDI, vector scope units, and I've got a feeling they're SDI only as well. So I don't have an analog vector scope that works. I have two one that doesn't work, and one that came with this job lot, and I haven't tested it yet. So I'm not going to quickly connect this to Vectorscope, but what I'm seeing so far is looking really good. I will leave this on test for a while. Well, I'm a little nervous about walking away and leaving this at the moment, but I will test it for some hours and see if it works reliably. In the meantime, we could read the instructions, couldn't we? Well, I don't think these instructions are out in the wild, and if they're not, then I will scan them in. Bit of a pain with my particular scanner, but I will make these available to the world because these are very sought after, the DPS 375 and its NTSC equivalent, the DPS 275. Now this is what we need. A technical manual, DPS part number 708375, is available, which contains extensive theory and maintenance information in the unit conjunction with schematics and silks. So that's what we need. Yeah, I don't suppose there's anybody got one of those to hand. That could really use scanning in. That's interesting. PAL video input, composite video input for connection to VTR NTSC video output. NTSC? Does it mean that? I think that might be a typo. S video input, component YC443. So that should be that one. YC dub input 685 and 924, so I think that's trying to say for low band or high band, but do you know, I've never seen that actually need to change whether I'm playing low or high band tape, so something somewhere must automatically handle that. Well, they're Y, R, Y, B and Y, so there's YUV inputs for M2 or Betacam. Nobody uses M2. M2 is a forgotten format. Nobody in the world runs it except me. And DOC input, dropout compensator input. So that's the RF output from the heads. It can be RF or TTL selected by internal jumper. I didn't even know that. PAL video output 1, that's what we're connected to now, and 2 is the same, and then S video YC dub, so that's if you wanted to go out to a U-matic video recorder, and similarly out to M2 or Betacam. So the sync is a composite sync, 16 horizontal lines ahead of the output video, used for timecode editing. So that's why you might want that going back to the video recorder, but we're not going to need that. And then reference video, so that's used in studios where everything has the same timing. Right, so we've done the connections. We know how to connect it up to a U-matic video recorder because I have several of these in use for that very same function. You can save your settings, something I've never really understood, so I'm going to have to read that. Yes, you have a freeze function, and you can freeze field or frame, which not something I'm worried about. Mosaic, oh, why does everything have that stupid feature? Don't want that. And posterior, yeah, don't want those. And we've been using these functions here. Just drop the receipt. So the internal dip switches are just in here, but awkward to get to. You have to undo all the screws to get to the dip switches. Why do they put them there? Okay, so Betacam levels and vertical blanking, dub out for low or high band machines. Okay, so 924 is for high band and SP. So I think because I'm using high band machines, I'm always in 924 mode. And 685 would be for a low band machine like the one that you can't see that's right beside you. Okay, dropout compensator for PAL and NTS for PAL or RF. We've never noticed this. Oh yeah, and delay signals for the... We didn't know all this was available. It's really good to find this. So in theory then, if I select YC443, I should be on this. Yes, I am. Oh, good. But am I on S video input? Let's disconnect the composite input. Yes. Yes, we are. So that's S video in. So that could be useful for any source that has S video and doesn't have YUV, or you don't want to use YUV. So you might connect that, for example, to certain Betacam machines like the UVW1800P, which has S video output, and so do some M2 machines, if for some reason you don't want to use a component. Right, so we're going to leave that on test for a while. I do believe the fans are quietening down now. That's good. Alright, it's the next day. This has been sat here idle for some time. Let's see. Well, if it works. So I've just done test select on the source machine, and it's obviously doing the pass through. So let's see if it works. No, it doesn't. So we're still getting this strange effect when in process. Bypass is working, test is sort of half working, and that's process. Colours are, it's just weird. Let's try a bit of gentle heating. This is only set to 100, and of course the problem could be on a board beneath, but it's presumably thermal. Oh look, suddenly improved when I went into this area. But of course it could have just done that anyway, but it seemed to be this area. So maybe I need a bit of freezer in that area. Or we could try an inverted duster. Can we bring the fault back? No, it could well be on a board beneath. But I think it's quite likely that it is thermal. I'll have to pop the boards up if I can do that and still operate the machine. What about the possibility it's power supply? I'm not sure I want to squirt freezer in a power supply. I'm thinking of having a quick look at the power rails. I don't think this is a power supply problem, but even so. And one of the things I was thinking is, well, I could get to the power supply connectors here if I take this metalwork off. But since I want to have a look at the boards underneath anyway, let's see if I can get to this connector that goes on the lower board here and look at some of the voltages there, especially when it's been switched off for a while. So it's now been off for some hours. These screws don't feel like they've been undone since manufacture. Last time I had a capacitor explode on one of these, it was around here, I think, on the top. And it was just a 0.1 microfarad decoupling capacitor. It wasn't even a tantalum. I think it was just a normal 0.1 microfarad cap, and it just exploded. Went up in a big cloud of smoke. So that was an easy enough fix. Right, how much access do we have? Insulation and screening metal there. Speaking of insulation, I don't want any of this to touch this. So let's make sure it doesn't. Okay, well, there's nothing on the bottom there that should be temperature sensitive. I see there is a Dallas chip, so presumably that's for storing the settings, and presumably that doesn't work anymore. So here's our connector for the power. Let's get a multimeter on that. Of course, we're guessing at what voltage is what because we've got no schematics, but you know, it's going to be relatively obvious, I hope. So we have some red terminals here, so they're going to be probably 5 or 12 volts. Let's see what we see. Okay, let's see what we find on those red wires initially. 4.93 volts. And it's working fine now. Okay, well, the black ones are clearly going to be ground. Let's try what I think is a yellow terminal. I think that one's yellow. 12 volts pretty much. Back to the 5. So they look pretty stable to me. I don't believe they are our problem. Let's try a little bit of cooling. Fault seems to have gone away for the time being. The bottom board then looks to be a lot of the digital stuff. Got a Zilog processor in there, I think. So the Dallas backup. Lots of ROMs. And thankfully, not loads and loads of capacitors. Just a few at the very back there. Nope, the fault seems to have run away now. Oh, it's going to be a bit hard to fix if it fixes itself, isn't it? Okay, switch it back on again. I'm beginning to think that we're just going to have to call this a working machine because the fault is too transitory. You know, it's fully working now. It's in process mode. And so I think we should probably label it up. Words to the effect of allow to warm up for a few minutes before use. I think that's all we can do with it. Okay, I'll reassemble it and just remind you why this is such a special piece of equipment. Right, so we're going to erase all these markings about it being defective and label it as allow it to warm up. And I'm similarly, if I can get it off, going to erase these markings on this TPC about this being faulty because this is 100% perfect. Okay, some of these markings are not coming off so well. Never mind, tackle that later. I want to show you, remind you what's special about this machine. So what makes this Timebase corrector even more fantastic than any other is that it has dub in, and you can connect that to a U-matic video recorder which has dub connectors. Many do, but not quite all. You also connect the PAL in, which is that one, otherwise you don't get colour. And you also connect DOC in, which is RF out on the video recorder. So we've got dub. So the full connection set will be dub, PAL or composite video, and DOC, which is labeled RF out on the back of the video recorder. And then when the RF level falls too low, it will switch the digital dropout compensator on in here. But what makes this especially useful is this dub input, which allows it to process the luma and chroma separately in a similar way to S-video, but it's a different and incompatible signal. So that allows you to get the very best results out of U-matic, and it makes a really significant difference. And then I can take an output from either S-video or YUV and digitize that and get a really high quality U-matic copy. And if it's a first generation U-matic SP, the quality is actually really very good. It's starting to approach Betacam SP. So U-matic has a bit of bad press really, but it can give great results when used with a time-based corrector like this one. Right, so that's going to get labelled up. I will at some point scan in this and I'll make it available probably on my website, okay, Video 99 Co UK, so that we can all access these diagrams. This needs cleaning up. The only other thing to do today then is have a look at the, as I like to call it, Mark 1, which is the color video enhancer, no time-based corrector, and have a look at the power supply on that. These are a little bit fun to take apart, but I can do it. So let's do that next. Okay, let's open this one up. Now these are a little fiddly. You have to find which side you have to push and then release the clips on the other side. Yeah, they're fiddly. They always tend to lose their feet as well, like this one has. Okay, so the power supply is in this area, but we also wanted to check the socket because we thought that was a bit troublesome. Let's have a look. I'm not seeing anything wrong with the power supply connector. Well, the power connector soldering looks, well, reasonable. I'll resolder it anyway, and I'll also do some deoxit on the socket itself. Okay, having done that, let's go over to the capacitor here, which is the most likely cause, I think, of failure. You know, we had those bars running through the image. So it's supposed to be 2200 microfarad 16 volt. It's in circuit, but let's see what we can get. Did I mention got remote control foot switch for this ESR meter? I think I mentioned that before. Well, it says 3000 something, but over 20 ohms ESR. One thing is that you can't desolder it and test it, because in desoldering it, you reform it. Here's the capacitor in question. When desoldered, it will reform the capacitor. So kind of the only thing you can do is replace it anyway. I can try metering it now, but that heat is likely to have changed its characteristics. Oh, it reads absolutely fine. Nonetheless, we're going to replace it, aren't we? Right, before I fit a new capacitor, I'm going to check the bridge rectifier, because if one side of the bridge rectifier went open circuit, relatively unlikely I know, then you would get noise bars. One diode there, 0.5 volts, 0.5 volts, 0.5 volts, 0.5 volts. So, okay, so each diode is giving us about half a volt or so of forward voltage drop. So the bridge rectifier does appear to be in good order. We'll just change the capacitor. Okay, with a new capacitor installed there, and I've checked it's the right way around, I'm still not getting operation unless I lean on the switch, on the power connector. So that's not good. So we have a bit of a problem with that. Test select, that's working solidly now. So why is this power connector still playing up? I think the spring contact for the outer side is still contaminated. So I'll clean that with a fibre brush and I'll also spring it out slightly if I can with some kind of probe. Pull it slightly out so it applies a little bit more pressure. When trying to respring the leaf that sits on the side of the connector, I found that the center pin that goes in there was wobbling slightly, so I'm going to resolder that slightly on the back. Well, it's crimped at the moment and I just think that's spinning rather loosely, so I'll solder that if it'll take solder. But really I just need to get hold of a replacement power socket. Oh, it takes solder though. No, it's still not really reliable, as you can see, so we'll need to get a new power socket. Oh, look what I've just found. It's a DC power socket, it's the same type and it seems to have the same footprint, so I'll fit that. Let's see if it's reliable now. Ah, much better. Okay. Good. Okay, so that's where we're going to leave it. We have this TBC tested. There was not a fault with that one. This enhancer, which is now fixed, and the sophisticated TBC, which we believe is working good enough. The fault, such as it is, disappears after sometimes just a few seconds of switching it on. I don't think there's any prospect of being able to repair that, especially since we don't even have schematics for it. So I think we'll just have to label it up, run it for a few minutes before use. Right, the other thing is the user manual for this has not been something that's been available before. I'm going to scan it in. I might even stick it at the end of this video and I'll upload it to, there's one or other of the websites that has schematics and user manuals on it. I'll upload it to one of those so that they can be accessed easily. Hope you've enjoyed what we've done here today. I'll do plenty more content on audio and video technology in the near future. Bye for now. Do you remember a while ago I did a little video about the BEV8? It's a Sony 8mm rewinder. Well, I've been given a Jessup's 8mm rewinder. This is an unusual thing. For one thing, the tape goes in back to front, which is a little clunky, I would say. And then light comes on, so we can go, oh, that's forward and backwards, and that's start. So it does go both ways. There we go. This one doesn't erase tapes, whereas a BEV8 does. How do we stop it? Eject, you just sort of pull it open. And the BEV8 has an optical end of tape sensor. This one seems to be mechanical, which could possibly pull the tape off the spool if you've got a tape that's not in great condition. That's near the start, so we'll rewind this one back to the beginning. So we want it in rewind mode, start. It's got batteries in it, though I'd normally run them on a mains adapter. Oh, it seemed pretty gentle. When it got to the end, it stopped nicely. It's not a bad thing. So that's an unusual thing. Not come across that model before. I think I will get a mains adapter set up for that, and that can be one of my rewinders in the studio.